Hello guys, today we are going to see top 10 AWS Lambda questions and answers. So let's start with question number 1. What is AWS Lambda? AWS Lambda is a serverless computing service that enables you to run code without the need to provision or manage servers. With Lambda, you can execute code in response to various events, such as changes to data in Amazon S3 or HTTP requests from Amazon API Gateway or updates in Amazon Dynamod. AWS Lambda also provides automatic scaling, ensuring your application can handle workloads of any size without additional configuration. Question number 2. What are key features of AWS Lambda? First is serverless. AWS Lambda takes care of the underlying infrastructure, eliminating the need for server provisioning, scaling, or maintenance. You focus solely on writing code, and Lambda manages the rest. Second is event-driven. Lambda is designed to trigger functions in response to specific events, such as file uploads to S3, updates in Dynamod, or API calls via API Gateway. It integrates seamlessly with a variety of AWS services, making it an ideal choice for event-driven architectures. Third is scalability. Lambda automatically adjusts the number of concurrent executions based on incoming requests, whether it's one request per second or thousands. This scalability happens without requiring manual intervention. Fourth is pay-as-you-go. With Lambda, you pay only for the compute time you use. Charges are based on the number of requests, and the compute time measured in GB seconds. This model ensures cost optimization, especially for applications with infrequent workloads. Fifth is multi-language support. Lambda supports popular programming languages, including Python, Java, Node.js, Ruby, C#, and Go. You can also run custom runtime environments using Docker images. Sixth is execution limits. Lambda functions can run for up to 15 minutes per execution. You can allocate memory between 128 megabytes and 10 gigabytes, with CPU resources scaling proportionally to the memory. Question number 3. What are common use cases of AWS Lambda? First is real-time file processing. Lambda can process files such as images, videos, or documents as they are uploaded to servers. For instance, it can resize images or extract metadata from videos. Second is data transformation. It enables the transformation and movement of data between services. For example, processing data added to Dynamod or updating records in an Amazon Redshift table. Third is backend for APIs. By integrating Lambda with Amazon API Gateway, you can build serverless APIs to expose RESTful endpoints. Fourth is IoT data processing. Lambda processes IoT events from connected devices in real time when integrated with AWS IoT. Fifth is automation and monitoring. You can use Lambda to automate tasks like backups, log aggregation, or responding to CloudWatch alarms. For example, it can send notifications when specific conditions are met in logs. Sixth is machine learning inference. Lambda can execute inference tasks for machine learning models in response to incoming events. Question number 4. Explain components of AWS Lambda. AWS Lambda consists of several components. First is function code, the actual code that performs the task, uploaded as a zip file, container image, or edited directly in the AWS console. Second is event source, the trigger for the Lambda function, such as S3, Dynamod, SNS, API Gateway, or CloudWatch events. Third is execution role, an IAM role that provides the necessary permissions for the Lambda function to interact with AWS services. Fourth is environment variables, key value pairs that pass configuration settings into the Lambda function. Fifth is concurrency and memory allocation. You can configure memory allocation and control the number of concurrent executions to manage resource usage. Question number 5. How AWS Lambda works. AWS Lambda operates in 4 key steps. First is upload code. Write your function code and upload it to Lambda as a zip file or container image, or edit it directly in the AWS Management Console. Second is configure triggers. Define an event source, such as an S3 bucket or Dynamod table, to trigger the Lambda function. Third is execution. When an event occurs, Lambda automatically scales to execute the function in response. Fourth is return output. Lambda processes the event, runs the code, and returns the results to the source or another AWS service. What are benefits of AWS Lambda? First is cost savings. Pay only for the compute time and resources used, ensuring cost efficiency. Second is automatic scaling. Lambda scales seamlessly based on workload demands, eliminating the need for manual scaling efforts. Third is simplified infrastructure management. No need to manage servers, operating systems, or scaling configurations, freeing up time to focus on application development. Fourth is improved productivity. Developers can concentrate on writing code rather than infrastructure management, enhancing overall productivity. Question number 7. What are limitations of AWS Lambda? While Lambda offers many advantages, it does have a few limitations. First is execution time limit. Each function has a maximum execution time of 15 minutes. Second is memory and CPU constraints. The maximum memory allocation is 10 gigabytes, with proportional CPU resources. Third is cold start delay. Functions may experience a delay when invoked for the first time or after a period of inactivity, referred to as a cold start. Question number 8. How does AWS Lambda handle retries for failed executions? Answer: synchronous invocations. If a Lambda function is invoked synchronously and it fails, AWS Lambda returns an error response to the caller. The caller must handle retries, asynchronous invocations. For asynchronous invocations, Lambda automatically retries the execution twice with delays between attempts. Event sources with built-in retries. Certain services, like Amazon SQS and Dynamod Streams, handle retries using their own retry policies. Question number 9. What are AWS Lambda layers, and how are they used? AWS Lambda layers allow you to package external dependencies, libraries, or custom runtimes and share them across multiple Lambda functions. Use cases: share common libraries across functions to reduce duplication. Add custom runtime environments or dependencies. Simplify function deployment by keeping the code and dependencies separate. Example: use a Lambda layer to include a Python library like NumPy so it can be accessed by multiple functions without embedding it in each function. Question number 10. What are the security best practices for AWS Lambda? First is use least privilege IAM roles. Assign minimum permissions required for the Lambda function to operate. Second is environment variable encryption. Encrypt sensitive environment variables using AWS Key Management Service KMS. Third is enable VPC integration. Place Lambda functions inside a virtual private cloud VPC for better network security. Fourth is use a secrets manager or parameter store. Store sensitive information like database credentials securely. Fifth is regularly monitor logs. Use Amazon CloudWatch logs to monitor function activity and detect anomalies. Conclusion: AWS Lambda is a powerful and versatile serverless computing service that excels in building scalable, event-driven applications. Its cost-effective, pay-as-you-go model and automatic scaling make it an excellent choice for modern cloud applications. For workloads that don't require persistent server infrastructure, Lambda is a game changer. If you found this video helpful, give it a thumbs up, subscribe for more AWS Cloud-related services. Thank you.